This is where IAM roles come into play. IAM, or Identity and Access Management, allows you to create roles that grant specific permissions without sharing sensitive credentials. By setting up a role in the prod account, you can allow the dev account to assume that role. This way, the dev team can access the necessary resources securely and in a way that can be audited later. Think of it like giving someone a temporary key to a room instead of handing over your entire house key. They can enter when needed, but don't have full access all the time. In summary, using IAM roles helps you manage cross-account access securely and efficiently, ensuring that your resources remain protected. Cross-account access is a straightforward concept. It involves creating an IAM role in one account where your resources are located. This role has a trust policy that specifies which external account can assume it. Essentially, you are allowing a user or service from another account to access resources in your account securely. This is particularly useful when you want to share resources without compromising security. Think of it like lending a key to a trusted neighbor. You create a specific key, the IAM role, that only they can use, and you define the rules, the trust policy, about when and how they can use it. In summary, cross-account access helps maintain security while allowing necessary collaboration between different accounts. It's a vital practice for ensuring that permissions are managed correctly. In our scenario, we have a user in a development account and a role in a production account. The production account has an IAM role that allows read and write access to S3. This role also has a trust policy that specifically allows the user from the development account to assume it. When the user wants to perform an action, they request it from the development account. AWS then checks the trust policy to see if the action is permitted. Think of it like a club where the development account is a member who needs to access a special room in the production account. The room has a key, but only certain members are allowed to use it. The trust policy is like a guest list that confirms who can enter. In summary, users can assume roles in different accounts, and AWS verifies permissions through trust policies to ensure security. First, let's understand that temporary credentials are issued when we need to execute specific actions in a secure manner. In our lab practical, we will create an IAM role in the production account that has read and write access to S3. This role will also include a trust policy that specifies the development account, allowing it to assume this role. Next, in the development account, we will create an IAM user. This user will be granted permission to assume the role we just created in the production account. Think of it like giving a friend a key to your house, but only for a limited time and with specific instructions on what they can do inside. To recap, we are setting up a secure way to manage access between our production and development environments using IAM roles and temporary credentials. This ensures that we maintain security while allowing necessary actions to be performed. In this scenario, the user from the dev account will have the ability to read and write to the S3 bucket in the prod account. However, it's crucial to note that permanent credentials have not been shared. Instead, you can validate the access by checking the temporary credentials in the CloudTrail and STS console. This will help you confirm whether the user can indeed access the S3 bucket as intended. A common mistake that candidates often make is providing the wrong account ID in the trust policy or forgetting to include the assume role permission for the IAM user. These small errors can lead to access issues. To recap, a dev account user can access a prod account's S3 bucket with temporary credentials, but it's essential to ensure the trust policy and permissions are set correctly. When we work with temporary credentials, it's crucial to ensure that we configure both the trust policy and the IAM permissions correctly. This means we need to validate that access is granted solely through these temporary credentials. This approach helps maintain security and ensures that access is both secure and auditable. In cross-account access scenarios, IAM roles play a vital role by providing this secure, temporary access. Think of it like a guest pass at a concert. You get a temporary wristband that allows you to enter specific areas, but it expires after the event. Similarly, temporary credentials give users limited-time access to resources without compromising security. To recap, always remember that defining the trust policy and granting assume role permissions are critical steps in managing temporary credentials effectively. First, it's crucial to remember that you should never share your permanent credentials. These are sensitive and should be kept private to ensure the security of your account. If you ever need to deny access, remember that denying access always overrides any permissions that might have been granted. This means that if you set a deny rule, it will take precedence over any allow rules you might have in place. Additionally, temporary security token service (STS) credentials are often used for specific tasks. These credentials are short-lived and provide a way to grant temporary access without exposing your permanent credentials. Think of it like lending a friend a book. You wouldn't give them your entire library. Instead, you'd let them borrow just one book for a limited time. So to recap, always keep your permanent credentials private. Remember that deny rules take priority and use temporary credentials when necessary. If you found this video helpful, please like, subscribe, and let me know in the comments what advanced AWS topic you'd like to explore next.